So today we will see structure bit field. So before this double star. This is most important question for interview. Why? Because using character we can allocate 1 byte data. But suppose in my program I want only 2 bit data or 3 bit data, 5 bit data, 4 bit data, only form of the bits, not on the bytes. So how we can do? In C language only one method that allocate the how many bits you need, that much memory only, that is the structure bit field. Using structure you can allocate particular bits only. So structure field bit field, that means bit field is a mechanism where we can allocate a memory in the form of bits. What is the advantage of structure bit field? We can save the memory. Save the memory, that is the advantage. So we can use this bit fill mechanism in a structure and unions. What is the syntax? So syntax is first data type. So data type is either character or integer, anything. Then variable name. Then we have to put colon, then bits. Here you can put data type is any type or either character or either integer. If your data is less than 1 byte, then put character. If your data is more than 1 byte, then put integer, variable name, then colon, that bits, how many bits you need to allocate. But here colon is compulsory. Using colon, this variable will understand that how many bits we need to allocate, not a data. Here bits, that means that much memory will allocate. Here data type it should be either or character or integer only, not float or double. It should not be float or double possible. That means real number are not possible. So some of the suggested things. First check unsigned one. So always try to go here any data type you will use, that is the unsigned type. Because we need to allocate memory in the form of positive number, not a negative number. Because of that reason we have to use unsigned one. So first check unsigned one. Maximum go for unsigned. Address operator is not possible to apply for the bit field variable. Address operator is not possible to apply to bit field variable. Okay, so write down this, inform me once you complete. And one more thing, it is not possible to apply size of operator in bit field variable. Why? Because size of operator gives size in form of bits, bytes, not in bits. Size of operator gives in bytes, not bits. Okay, so we can write one program. I'll write here only. Structure A, I will take unsigned integer I colon 4. That means 4 bits of memory I have created. Then I will make variable of structure A1. Structure A1 is my variable. Then I will allocate A1 dot I is equal to 15. Then printf percentage %d slash n dash A1 dot I. My output is 15. So here I allocate the 4 bits of memory and I allocate the data and I am printing is. We cannot able to use size of operator in bit field variable. So because size of operator gives in the form of bytes, not bits. So in the next program, we will see how to check how many bits allocated in my program. Write down this program first. Next, p126.c. This is important for interview, how to find the size of bit field variable. We'll allocate here 5 bytes. Then main function, inside that I will create one count variable. That is my integer c is equal to 0. Structure a1 is my variable. A1 dot I is equal to 1. So I have store here 1. Now I will rotate my loop while A1 dot I is equal to true. So whenever it's true, it will come inside my loop. I will increment my count and I will check. I will do A1 dot I is equal to a1 dot I left shifted by one time. Then after completion this loop, I will do printf c is equal to percentage d slash n comma count. So I will store the one. Here I have the 5 bits. In the 0th location I have stored the 1. I am checking my a1 dot I is true, that means 1. Yes. See, count will be plus plus. Count plus plus, that means here one time. Then a1 dot I is equal to a1 left shifted by 1. Now my a1 dot this will be left shifted by 1. Now it's true, that means no non-zero. It will count will be increment. Here also 1. Now it's 4, that means non-zero. Count increment. 8. Here also 0, count increment. Here 1. This is also true, count increment. Then after this becomes 0 and this will come here 1. Here my area is nothing, so I have stored only 5 bits. So here my condition will become false. 7 dot I, that means this is the completely 0. Then my count, it will stop this and come here, and my count 5 will be printed. So like this way, this will check how many bits are available in my memory. Count is 5. Okay, so write down this. The next concept is structure padding. This is also most important for interview. Structure padding, that means memory alignment. So first I can say how to find my size of my structure. I will write the code. Here size of operator will work because we have stored the data. We will store the data in form of bytes. Struct1 integer I character ch float f struct1 o printf percentage d slash n dash size of o. So what is my size of o? What will be my output?
12 bytes.
Yes. So this is 4 byte, this is 1 byte, and this is 4 byte. 4 for 8 and 9 bytes, not 12. But that output should be 12 bytes. Output is 12 byte. Is generally we can think this is my 4 byte, this is my 1 byte, and this is my 4 byte. Then also it is showing me 12 bytes. Why? So it is storing like this in my memory. This is 4 byte for integer I. This is character bytes, and these are the wasted bytes. And these 4 bytes are for float. So whenever you allocate a memory integer I character ch, so that will not allocate 1 byte memory, but that my memory is allocating 4 byte memory here, and float is allocating 4 byte memory here. So we want 9 bytes, but instead of 9 bytes in the memory, it is allocating the 12 bytes. So these 3 bytes are wasted. So allocating a memory for structure variable is more than the required one is called structure padding. That is the this is the more than the required one. So that is the extra bytes. That extra bytes are creating the holes in my memory. These are the hole in my memory. So I write down this. Allocating a memory for structure variable, sorry, not structure, but structure variable more than the required one is called structure padding. That extra bytes which are used for holes in structure, so they are wasted on data, so they are creating the holes in my structure. So how it's happening in the compiler? Structure padding is in concept behind a compiler. How exactly it's work? So this also done, right? So I will erase this. Whenever we create the memory for integer, it is creating the 4 bytes data, that is called bank 0. So this is my compiler, this is my OS, and this is my hardware. When it will check the structure, how many bytes, how many data types are available. So first they will allocate the 4 bytes. bank 1 that is character, then also it allocate the 4 bytes. It will be inside the bank 1, and bank 2 it will also allocate 4 bytes. So here we need only 1 bytes instead of 4 bytes. This is wasting my memory. So how to do sorry for the compiler, at the time of compilation it will check how many bytes. According to bytes it will allocate the 4 bytes in the character, float or integer also. And OS is running behind that time, that is the scheduling OS, and hardware, inside the hardware our memory will created. Next question is how to avoid this structure padding, how to avoid this wall creation. So first question, interviewer will ask you what is structure padding exactly. So structure padding is nothing but whenever you allocate a memory, at that time it is allocating the memory more than required one. This is called structure padding. So give this example, integer I, character ch and float f. Using that we need only 9 bytes, that will allocate the 12 bytes, that is the 3 bytes is creation of wall in my memory, that is the structure padding. Next question is how to avoid structure padding, that we will see in the next program. Yeah, so first you will draw this diagram like this way. In the compiler, at the compilation stage it will allocation the memory. Next question is how to avoid structure padding. So for avoiding structure padding, that is the preprocessor directive, that is hashtag pragma back of 1. So this is my preprocessor directive. Here you can print f addresses of that percentage u percentage u, address of o.i, address of o.ch, my address of o.f. So this is the solution. Hashtag pragma pack of 1. So what is the hashtag pragma? Hashtag pragma is the preprocessor directive. This is the pack of 1 and these are the numbers. It will change compiler to compiler. We are using the GCC compiler. So according to GCC compiler manual, we have to use avoid structure padding hashtag pragma pack of 1. So more than how many hashtag pragma pack are available. So you have to search for that your compiler's manual hashtag pragma for the GCC compiler, and you can see that much directive are available different. So pack of 1 is useful for the avoid structure padding. So using a hashtag pragma pack of 1, that will inform compilers that to in the your structure how many bytes are available, that much byte data you need to allocate. So 9 byte data allocate. My o.i address is the 15. Then 4 byte data is allocated for that, and o.ch starting address is 19, and o.f starting address is 20. So the here only 1 byte data allocate. Suppose I will remove this hashtag pragma pack of 1. So here 12 byte data allocate, 4 bytes for each. So using pragma pack of 1, we can avoid structure padding. Okay, so it is starting from 15, 19 and 20. Okay, so write down this. Hashtag pragma is the preprocessor directive, and it will inform compiler to how many bytes of data you need to allocate for my structure. That means avoid the structure padding. Understood this concept structure padding, what is structure padding and how it's allocated and all things. Any questions? Pooja?
No.
Okay. You was waiting for this concept.
Yes.
So what many students are doing mistake in their understanding. Once I was the beginner, that time I have also did that mistake. This year, without hashtag pragma pack, it is creating 12 bytes. What was my understanding was that is wrong misunderstanding peoples are doing. My understanding was, suppose I have created the I is equal to 10. 10, that means how many bits allocated? Only 4 bits allocated. That means 1010 it will, yeah, complete in here only. This is my first byte 0000 1010. Rest of all bits are 000. This is my integer. So what was my understanding is this. I have created the 10, that means I am using the 4 bits only, or rest of bits are not usable. That is the using structure padding we are deleting this memory. But that is not concept. That is the misunderstanding. The concept is when you use integer I, that also 4 bytes allocate, character that also 4 byte allocate, and float that also 4 byte. But here we need only 1 byte, not 4 byte. So avoid this type of holes in my memory. For that we are using the structure padding. So this is the general mistake people are doing. Okay, done this. One more thing, have you noticed in the structure when we created integer I, that means also separate memory created for the integer I. Character F, that is also separate memory created. Float F, that means also separate memory here created. This 4 byte, this 4 byte, this 4 byte, this all are the separated. That means independent.